Galileo Galilei, most people simply call him Galileo, was one of the most significant people in the history of science. He lived at a crucial crossroads in time when different strands of thought met and clashed. These were natural philosophy based on Aristotle's incorrect ideas, the beliefs of the Catholic Church, evidence-based scientific research. In the end, the ideas of Galileo and other scientists triumphed because they were able to prove them to be true. Although his ideas triumphed, Galileo paid a high price for his science. He spent the last 8 years of his life under house arrest, and the Catholic Church banned the publication of anything written by him. Galileo's early years and education. Galileo Galilei was born in the Italian city of Pisa on February 15, 1564. He was the eldest son of Vincenzo Galilei and Giulia Aminotti. His father was a well-known composer who played the lute, a stringed instrument. Galileo also became a skilled lute player. As a young man, Galileo was torn between training to become a Catholic priest or a doctor of medicine. His father encouraged him to study medicine, and Galileo took his father's advice, starting a medical course at the University of Pisa when he was 17 years old. Soon, however, his father's plans came unstuck. Aged 18, Galileo stumbled into a mathematics lecture, changing his life and the course of scientific history. Mathematics seemed so much more interesting than medicine, he thought, and he quickly realized that mathematics seemed to play a crucial role in understanding and explaining our world. Galileo became fascinated by the movement of pendulums, noting that if the length of the string was constant, it didn't matter how hard you swung it, the pendulum always moved to and fro at the same rate. The musician in him recognized a principle similar to his lute. It didn't matter how hard you hit a lute string, it would always play the same note, but if you changed the length of the string, you could change the musical note. And likewise, a pendulum would change the rate at which it swung to and fro, only if you changed the length of the string. As an accomplished musician, Galileo knew that the relationship between string length and the note it produced was mathematical. This had been proved almost 2,000 years earlier by the Pythagoreans in ancient Greece. In fact, Galileo's father had contributed to the field of the mathematics of music by discovering a new relationship, showing that in a stringed instrument, the pitch of a musical note depends on the square root of the string's tension. And so the die was cast. Galileo realized that he was much more interested in mathematics and physics than he was in medicine. He chose to follow the path which excited him most intellectually, rather than that which would have rewarded him most financially. Having strayed from medicine, he decided he might as well study art and drawing in addition to science. Funnily enough, he never completed his university degree. Galileo's scientific career. At the age of 22, Galileo published a book about a hydrostatic balance he had invented. In this way, his name became known to other scientists. Despite his scientific progress, Galileo's first job was as an art teacher. Aged 24, he began teaching art in the Italian city of Florence. He didn't stay long in this job. His scientific and mathematical powers had been noticed, and in 1589, aged just 25, he was awarded the chair of mathematics at the University of Pisa. He worked in Pisa for 3 years before moving to the University of Padua in northern Italy in 1592. Galileo settled in Padua, where he taught mathematics, physics, and astronomy, making many momentous scientific discoveries. Galileo's scientific achievements and discoveries was the first person to study the sky with a telescope. Became a skilled telescope builder and made money selling them to merchants in Venice, who were eager to see which ships were arriving as soon as possible in an effort to make money on the futures market. Discovered the first moons ever known to orbit a planet other than Earth. Jupiter's 4 largest moons, which he discovered, Io, Europa, Ganymede, and Callisto, are together known as the Galilean satellites in his honor. Discovered that Venus has phases like the moon, ranging from a thin crescent to full. This was the first practical observational evidence that the sun sits at the center of the solar system. Discovered the rings of Saturn, although he found their appearance very confusing. Discovered our moon has mountains. Discovered that the Milky Way is made up of stars. Was the first person ever to see the planet Neptune. We know this from drawings in his notebook. He observed that it was moving, unlike the other stars. In Galileo's time, the planets Mercury, Venus, Mars, Jupiter, and Saturn had been known of for thousands of years, and no others were contemplated. Unfortunately, Galileo lost track of the moving star he had found. Neptune was not discovered until 1846. Established that, if there is no air resistance, everything falls to the ground at the same rate regardless of its weight. Gravity accelerates all objects equally, whatever their mass. established that when gravity accelerates any object, the object accelerates at a constant rate so that the distance fallen is proportional to the time squared. For example, a ball falling for 1 second would travel a distance of 1 unit, a ball falling for 2 seconds would travel a distance of 4 units, a ball falling for 3 seconds would travel a distance of 9 units, etc. It is probably a myth that he discovered this by dropping cannonballs from the Leaning Tower of Pisa. He used balls rolling down wooden ramps for most of his investigations of gravity and acceleration. Identified that anything thrown or fired on Earth, such as a rock or a cannonball, flies along a curved path, and that the shape of the curve is a parabola. Stated the principle of inertia. A body moving on a level surface will continue in the same direction at a constant speed unless disturbed. This later became Newton's first law of motion. Proposed the first theory of relativity. That the laws of physics are the same for all observers moving in a straight line at constant speed. Discovered that for pendulums, their period of oscillation squared is directly proportional to their length and is independent of the mass attached to the string or rod. Galileo realized pendulums could be used to keep time, but never seems to have put this into practice, other than showing his son a design for a clock. Clocks had not been invented in Galileo's time, and his experiments were conducted using his pulse as the timekeeper, or, better, the weight of water which escaped through a hole in a vessel. Tried to measure the speed of light, but found it was too fast for him to measure. Showed that the set of perfect squares 1, 4, 9, 16, 25, 36, 49, 64, 81, 100 has as many members in it as the set of whole numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, even though, at first sight, the set of whole numbers appears to contain more members. This demonstration became known as Galileo's paradox. The basis of Galileo's proof is that there must be as many whole numbers squared as there are whole numbers, because every whole number can be squared, so every whole number can be paired up with its square. Galileo's trouble with the church. In Galileo's time, the church reluctantly tried to accommodate science to some extent. Roughly speaking, its attitude was that it was okay for you to do science, and it was even okay if you find that the church's interpretation of the Bible was wrong, as long as you didn't say it out loud. For example, it was okay to pretend that the Earth orbited the Sun to help with astronomical calculations, but it was not okay to state that it was true that the Earth orbited the Sun. Galileo's troubles began in 1613 when he was 49 years old and published Letters on Sunspots. In this book, he established the imperfection of the heavens by describing dark patches on the Sun's surface, sunspots. He also said he preferred the idea that the Earth orbits the Sun to the idea that the Earth is the center of the universe. This was known as the Copernican view after Nicholas Copernicus proposed a heliocentric or sun-centered solar system in 1543. Aristarchus, in ancient Greece, proposed this 18 centuries earlier. Copernicus's work was well known to scientists, but the church had never approved the book for general reading. In 1615, Galileo wrote that the Bible's words had to be interpreted based on modern science and that the language of the Bible was the language of an earlier time. In 1616, the church went further than non-approval of Copernicus's book, condemning it and banning it. In 1620, the church approved Copernicus's book after editing it. Any sentences in which Copernicus wrote about a heliocentric solar system as a matter of fact were removed or changed. Despite the final approval, the book was still not actually published in any countries with a powerful Catholic Church. In 1632, the church in Florence, but not Rome, approved for publication Galileo's new work, Dialogue Concerning the Two Chief World Systems. In the book, he seemed to argue in favor of a heliocentric solar system. In 1633, Galileo answered a summons to Rome to answer charges that the Dialogue Concerning the Two Chief World Systems was heretical. He was interrogated by the Inquisition and threatened with torture. He denied that his book was heretical and denied that it advocated a heliocentric solar system. He was sentenced to life imprisonment on the basis that he was vehemently suspected of heresy. This was later lessened to house arrest because he was a rather elderly man. Dialogue Concerning the Two Chief World Systems and all other works by Galileo were prohibited. However, in countries where the Catholic Church was not strong, such as England, Holland, Germany, Scotland, Switzerland, and all of Scandinavia, Galileo's books were available for anyone to read. House arrest and two new sciences. Galileo was confined to his house in the city of Florence for 8 years, during which time he was allowed to receive visitors. In 1638, he published his masterpiece, Discourses and Mathematical Demonstrations Concerning the Two New Sciences. The two new sciences he described were the science of materials and the science of motion. The book was published in Holland after it was smuggled out of Italy. It contained much of what Galileo had discovered and learned during his many years of experimentation and theorizing. After 8 years of house arrest, Galileo Galilei died on January 8, 1642, aged 77. As the years passed, the Catholic Church gradually began removing prohibition orders on some of Galileo's books or allowed edited versions to be published. It took until 1835 until everything Galileo had written was approved by the Church.